as Jen said, I'm going to present to you now one of a project that the Competitiveness, Technology and Innovation Division within the Inter-American Development Bank. I participated in this project, which is about gender gaps in science, technology and innovation within the Latin American and Caribbean region. So what you see on the left is was made by a very famous Argentinian cartoonist called Kino, and the strip is called Mafalda. It's very famous in Latin America, and this reflects a lot, Latin American society, what is happening, and so basically what is asking. The first one here, what is asking is, what are you asking in the future? And the other one is saying, well, women engineers. So that reflects a lot what are the preoccupation of Latin American society. So Latin America in general is facing a development challenge. The difference in GDP per capita between Latin America and the US has been growing over time. So it's higher since 1960. And one of the main problem of Latin America is they have a very low productivity. Despite the fact that Latin America has had quite a high growth in the past decade, this was not due mainly to productivity, but more to factor accumulation. So as you see here on the curve, Latin American productivity has gone down, and this relative to the US in 1960. And when you look also, so that's the curve, the red curve. And if you look at the curve on top, which is the blue curve, that's the curve that corresponds to the relative productivity of East Asian country. What is interesting is in 1960, in the 60s, productivity, the development level in East Asia and Latin America was very similar. So there is a big problem here, and well, it's important to see what is the issue here. So everybody, this is common knowledge that innovation is an important driver of economic growth. But the problem in Latin America is this idea has not yet been assimilated, and this is reflected in very low spending, for example, in innovation and development as percentage of GDP. As you see here, Latin America has 0.7% of GDP spent in innovation and development, compared to Korea and Israel, which is superior to 4%. This is also reflected in very few researchers in general. So you see that for 1,000 members of the labor force, Latin America has 1.6 researcher compared to 8.6 in the US and 7.63 in the OECD. And this is also the same when you look at only women researchers. So this is coming from the IDB project, the launch of an IDB project, which was to look a bit more on the problem of gender in science and technology. And so this is a project that started in September 2015 and ended in March of this year. And this project had three components. One is measurement, a second one is research, and a third one is awareness. So measurement the idea was to do a pilot for the collection of gender gap indicators in science, technology, and innovation within the Latin American region. There was also a component which was the research on gender gaps in science, technology, and innovation, and their economic costs for Latin America. And finally, there was an awareness campaign which was aimed at promoting awareness, dialogue, action for gender equality in STI-related occupation, in terms of the access, in terms of scientific productivity, as well as career progression. So I'm going to talk mainly about, today I'm going to talk mainly about measurement. So the first phase of this part of the project was to do an initial review and assessment of the best practice. So we looked a bit at what other regions, other countries were doing, other international organizations as well, so that we could come up with a conceptual framework that is, so that we could get indicators that are comparable with other regions of the world. Given the framework that we came up with, that I will present right after that, we did a questionnaire, so that we sent this questionnaire to Latin American countries to understand the data availability the data that we could collect on this gender. And based on the results, we decided to include 4 countries in the pilot data collection. So the 4 countries are Chile, Colombia, Mexico, and Panama. So the reason why we picked these countries were because to have capture a bit the heterogeneity of the region in terms of the size, in terms of the location, and in terms of the economic development. So this is the conceptual framework and the indicators that we try to collect during the process of the pilot data collection to measure gender gap in STI. So we split it in 4 areas. One is higher education in science, technology, engineering, and mathematics. We collected indicators on enrollments in STEM, education staff in STEM, and leadership position in higher education institution to try to understand if there is a ceiling effect or not, glass ceiling effect or not. Then we looked at careers in science and technologies, so employment in occupation and industry related to science and technology, human resources in science and technology, and also labor market conditions related to science and technology. So that was salary, data on the salaries. Then we looked at scientific research, and we collected indicators on researcher by sector of employment, researcher by science fields, R&D staff, financing of research, and publication in scientific journals. So this was, the last one was with the help of Elsevier that gave us the data. And finally, we had one more area on innovation and innovative entrepreneurship. So this area was the most challenging in terms of the availability of the indicators. So this was the indicators that we initially wanted to collect, which was the creation of companies with high growth potential, patents, which I will present after, innovation in firms, and awards for innovation. This one was very difficult, mainly because innovation and innovative entrepreneurship, we get this data from surveys, innovation survey, economic surveys, and usually in the case of Latin American countries, first they are usually just starting to do innovation survey or this kind of surveys, and second, they are not always have a gender breakdown, so it's usually difficult to get this data. So I'm going to present quickly some of the results that we got from these indicators. So in terms of higher education in STEM, so this is indicators on the share of women enrolled in STEM field at the PhD level, so in 2015. So here we got data from Mexico, Chile, and Colombia. So what you see here is basically in 2 fields, which are engineering, industry, and construction, but especially computer science. Women are very poorly represented. So we have also had another indicators on the distribution by sex of the leadership position in universities. So here we could only get data from Chile and Panama. And you see that, especially in Chile, you have evidence of a glass ceiling effect in higher education because it's mostly men are in high leadership position in universities. So these are data. This is an indicators on gender gap in careers in science and technology. This is the share of women in human resources in science and technology. The first one in blue is the share of women that are educated in science and technology, and the one in orange are the share of women that are employed in science and technology. And what is interesting to see is that in both Chile and Mexico, you see that the share of women that are educated in science and technology is much higher than the share of women that is employed in science and technology. So this would suggest a leaking pipeline at this level. Then scientific research, we could get quite a lot of indicators compared to other areas. So one of the indicators was the share of women in R&D personnel by category in 2015. So we usually get more years, but for simplification, I usually average the data. So if you see here, you have researchers that have a low share of women compared to technician, other support staff, and especially in Chile and Mexico. Okay. Then we looked at the share of women researchers by sector of employment. What you see here is there is a very little representation of a woman researcher in the private sector, especially, and this is especially the case in Colombia. This is data that we collected that was sent from Elsevier, so they collaborated with us on this project. And here you see that the proportion of women among name, gender, author profile is pretty similar, like for the countries of our pilot, Chile, Mexico, and Colombia, is pretty similar to the European Union. But compared to Brazil, is quite low. Okay, so we got also data that with WIPO, who also collaborated with us on this project. So these are patent application by sex of inventor. So this is an average from 2010 to 2016. And what you see here is the share of from all the patent application, the share of only women inventors is very small, and especially for Chile and Panama. But you can also see, and this is quite interesting, mixed teams. Whenever you have mixed inventors, men and women, it's also quite low when it comes to patent application. So that was an interesting result. And finally, this is something that we got from the Innovation Survey of Colombia, which is quite rich in terms of data. And so we could calculate the rate of innovation by level of parity. So that's the first quadrant, and you see that the rate of innovation for firms that have a high level of parity is 5 times higher than the rate of innovation for firms with low level of parity. And similar results can be seen with innovation spending as percentage of sales. So some preliminary conclusion. So we can see here that also, although some indicators show some progress, there is still a consistent gap that is maintained, and especially in some areas, computer science, engineering, also the private sectors. There are also barriers to occupational progression. We've seen evidence of glass ceiling effect and leaking pipeline effect. And finally, there are barriers to transition to employment, and this is especially the case in employment in the private sector. So just a few words on the data collection exercise. So it was quite challenging to get indicators because of the design of the surveys and some other instruments of data collection of STI. So we don't necessarily have a gender breakdown with other breakdowns that are interesting for us. There were also, we ran into institutional barriers. Sometimes it was difficult to coordinate because the data come from different agencies within the government, so it could be statistical agency, different ministries, so that was a bit challenging. And also because gender issue is not necessarily a priority, and sometimes it's even absent from for governments in Latin America. So there is a work that is needed in harmonization, formalization, to basically highlight the importance of following the international guidelines for comparability between indicators with within Latin America and the rest. And there is a need to integrate gender dimension in indicators for development and monitoring of better public policy in STI. So you can download this. So this is something that I didn't talk about. These are part of the project. This is research which was done, new empirical evidence on the cost of gender gaps in STI in Latin America. So this you can also have a look on the website. And I think that's it. Just the next step, finally. So the IDB will try to support the dialogue with national agency and RECIT, which is an organism that collects data in Latin America, to expand the scope of the pilot countries and indicators, and promote the effort to develop indicators, a wider range of indicators, more detailed indicators. Thank you.